Hey 8th graders, today's lesson is 3.1 light waves. In the last couple lessons we've kind of talked about what different types of light there are and how those can either cause damage or not cause damage or have some other change to an object based on the size of their wavelength. In the last lesson, 2.2, 2.4 and 2.5, you guys also looked at the 7 different types of light that we find in the sun. You guys got to see kind of which 5 of those types of light actually hit the earth and would affect our skin. You guys got to learn a little bit about of those 5 types of light, which ones cause damage to our DNA, okay, and what happens to the energy when it hits from those types of light when it hits your DNA, and what happens if your DNA absorbs certain types of light. And you guys also kind of started to pull that back into this whole Australia concept where we have Australia having higher skin cancer rate and having to do with those 3 claims. Right now we kind of narrowed it down to claim 2 and claim 3, that there's something different about the light in Australia and there's something different with the people's skin in Australia. So with that being said, today we're starting chapter 3. Your learning targets for today are that you can differentiate between absorbed light, reflected light, and transmitted light. So one of the things that we've kind of talked about through some of the key concepts we've had in this unit so far is that when light is absorbed, okay, what can happen to certain objects, but what happens if light isn't absorbed? So that's really going to be our focus in today's lesson is, other than absorption of light, what else can happen with light? Okay, so this is where we're going to bring in these terms reflected light and transmitted light, and we'll figure out how that affects objects. And then you can also determine whether different types of objects will absorb, reflect, or transmit different types of light. And this is going to kind of help us solve our little mystery that we've got going on with the Australian skin cancer rates. Okay, so with that being said, activity 1 notebook. You guys can open up your OneNote, add transmit and reflect to your vocab. So transmit is also known as transmission in the noun form. Okay, so we can call it transmission. And that means to pass through. So if light hits an object, it can pass through it or be transmitted by that object. Okay, reflect is to bounce off without absorbing. So when we look at absorbing, the light just kind of goes into the object and that's it. It disappears. Okay, reflect means that it goes to the object and then bounces right back out. Okay, so to bounce off without absorbing, and again, the noun form of that is reflection. Okay, and then add key concept 9 and 10 to your key concepts page. Key concept number 9, light travels in a straight line. And key concept 10, when a light hits a material, the light can be absorbed by the material, transmitted through the material, or reflected off the material. So again, we kind of talked about what happens if light isn't absorbed from these key concepts. You guys can see that there's 2 other options. It can either be transmitted and go straight through the object, or it can be reflected and bounce off the object. Okay, so aside from being absorbed, that's what can happen. Okay, moving on to your activity 2 warm up. You've learned that light from the sun includes different types of light. Okay, there's 7. 5 of them actually reach the earth, including gamma rays, X-rays, ultraviolet light, infrared light, microwaves, radio waves, and visible light. You've also learned that Australia gets more UV light than any other part of the world. But why? And that's what we're going to learn in the next lesson. Okay, but what we've been kind of comparing to is Brazil, and you guys can see Brazil has less of that yellowish color here, meaning they have less UV light that's hitting them. But again, the question is why? Okay, why is Australia getting more UV? Okay, so why does Australia get more UV light than other parts of the world? What are some of your initial ideas? So what are your guesses about that? So go ahead and record your answers there. If you guys need to, take a second, pause this video, finish up your activity 1 notebook and your activity 2 warm up, and when you're done, come on back to this video and we'll do activity 3, or talk about activity 3, which is a little hands-on experiment. All right, so usually I have a little video to help you guys navigate any hands-on if you're at home. Unfortunately, this just won't work for this little hands-on activity. So you guys might be able to finish a good portion of this assignment at home with the exception of activity 3. You will need to come make up activity 3 with me. Okay, so I cannot grade this, or I won't grade this until you guys have come in, maybe during advisor. You guys don't have a lot of school left. but make up this hands-on activity. The whole goal of it is you guys have some items on a tray, and your goal is to get a laser pointer to touch all of those objects on your tray, or to go through or to have some kind of contact with all objects on the tray with just the one laser pointer. So your mission is to set up the material so that the red light from the laser touches every object in its path. During this mission, you will gather evidence to support or refute these claims about how light moves. So again, this is all in the investigation to be like, all right, if we have a light ray or a wave of light, how does it move? So claim 1, light can travel in a curved line. Claim 2, light can go through a material. Claim 3, light can bounce off a material. Okay, so again, come see me about activity 3. Again, you guys won't be able to do slides 5 or 6 without doing that. Okay, so let's move on to activity 4, the sim. Predictions about glass and aluminum with a partner. Actually, you guys are just working by yourself at home. Discuss the types of light you think will pass through glass and which type will pass through aluminum foil. So remember, there's 7 types that we've looked at. 5 of them hit the earth. So if we were to shoot those different types of light at glass and aluminum foil, which do you guys think will bounce off, okay, and be reflected? Which do you think will go straight through it and be transmitted? Or which do you think will be absorbed? Okay, and we should already know a little bit about the absorption of these from the experiments we've done in the Sims so far. Okay, so let's first make some predictions. I predict that all types of light will pass through the glass, which is what we've seen with a couple so far. Okay, some types of light will pass through the glass. Remember, there's 7 types of light that we're going to look at. Or that no light will pass through the glass. So circle your prediction there. And I predict that blank will pass through aluminum foil. So what do you think will pass through aluminum foil? All types of those 7, some types of those 7, or no light at all. Okay, once you guys have your prediction done, let's go ahead and test this theory in the sim. Investigate what happens when light hits glass and when light hits aluminum foil. Remember, if the light is taken in by the material, it's absorbed. If the light passes through the material, it is transmitted. And if the light bounces off the material, it is reflected. So here is a little image to show you guys those 3 things. So this little black arrow represents the pathway of light. So here's transmission. It goes straight through and comes out the other side. Here's reflection. It hits the object and then comes back away from it. And here's absorption. It goes right into that and then it stays there. Okay, the energy from that light stays in that object. Okay, so how you guys will work the sim. Obviously, you guys will open up your sim. Okay, you will choose laser and turn the light source on. So let's go ahead and get our laser. We're going to turn it on. Remember, with the laser, we can kind of scroll to get the different types of light, which we can't do with the other sources of light unless we do a custom wave, but this is just a little bit easier. Okay, drag the glass to the platform in the testing area. Okay, so move the slider to select different types of light and test how they interact with glass. So you guys are going to test all 7 types of light, okay, and see how they interact with that glass. Record the results. Okay, so if we look on slide 10 down here, okay, you guys will test gamma ray, X-ray, ultraviolet, visible, infrared, microwave, and radio wave. You guys have 3 options for what the light does for each of those 7 types of light. So when it hits the glass, is it absorbed, transmitted, or reflected? So let's go ahead and take a look. Let's pick our glass up. We'll go ahead and start with gamma rays for our example. So gamma rays come here. I'm going to also do show energy because that gives me just a little bit better idea. So if we shoot gamma rays at my glass, it looks like they are going all the way through and coming out the other side. So for gamma rays, I would go to transmit. Okay, then I would change the type of light to X-rays and see what happens to those yellow arrows. Make sure you guys have your show energy toggle on because it does a really good job of showing, all right, these arrows are going all the way through, whereas I can't necessarily see that the best here. So just keep that in mind. It just shows you guys a little bit better what's happening to that energy. Okay, so you go through test X-ray, ultraviolet, visible, infrared, and microwave and radio wave, and then you guys are doing the same thing for aluminum foil. So now change your glass out with aluminum foil. And, oops, not genetic material, aluminum foil. And again, test that. It looks like gamma rays are also going through my aluminum foil. So I would grab my marker and I would write transmitted or highlighted or however you guys choose to do it. I'd put that that's transmitted as well. And that won't always be the case for all of these. So don't assume these lights are all going to be transmitted and move through. Okay, so test basically 14 different tests here, 7 different types of light on glass, and 7 different types of light on aluminum foil. So both of these data tables should have something circled for each type of light. Okay, again, 2 are already done for you guys. And then answer these questions. Did the same thing happen to every type of light when it hit the glass? Use evidence from the sim to explain your answer. So obviously you guys got to answer. Did the same thing happen, yes or no? And then explain. Okay, what did you guys see in the sim? Okay, and then did the same thing happen to every type of light when it hit the aluminum foil? Again, yes or no? And then explain what you guys saw in the sim. Okay, go ahead, take a second to finish up the sim through slide 13. Pause this video, and when you're ready, come on back and I'll explain the last part today, which is the homework. Okay, so for activity 5, you guys have a little homework assignment to read how fiber optics work. So we use fiber optic for a lot of our communications today. So read a little bit about what fiber optics are, how the cables are kind of arranged, and how we use those for sending waves. Okay, so read about fiber optics and then answer these 2 questions here. How does fiber optic cable send information quickly over long distances? And why are digital signals an accurate and reliable way to record and send information? So answer those 2 questions and then you guys can go ahead and do your wrap up. Circle if you have any questions and type them down if you do. And then 4, 3, 2, 1, how do you think you did? Go ahead, let your assignment save before you hand it in. And I hope you all are having a great day. Bye.